According to the National Electrical Code, the size of the feeder conductors before the fuses must be rated to protect the equipment served by the feeder. The equipment protection device, such as a fuse, must be selected based on the overcurrent protection requirement of the equipment. Consider an example involving a 125 amp incoming service, fuses for a motor starter, and a distribution block stepping down to 12 American wire gauge wire. The issue here is that the 12 American wire gauge wire after the distribution block is not rated to protect the equipment served by the feeder, specifically the motor starter. The fuse should be selected to protect the motor starter and the feeder conductors before the fuse must be sized accordingly. A correct installation would involve several steps. Firstly, use a feeder conductor size that is rated to protect the motor starter, referencing NEC Table 310.16 for appropriate sizing. Secondly, place a fuse rated for the full load current of the motor starter before the distribution block. Thirdly, step down the wire size after the fuse to 12 American wire gauge if required for the distribution block. The described wiring configuration is incorrect and potentially hazardous. The feeder conductors before the fusing should be sized to protect the equipment served by the feeder, and the distribution block should be provided with overcurrent protection in the form of a fuse before reducing the wire size. To elaborate further, the National Electrical Code provides comprehensive guidelines to ensure electrical safety and proper installation practices. These guidelines are not arbitrary, but are based on sound engineering principles and extensive testing to minimize the risk of electrical hazards such as fires and shocks. When dealing with electrical systems, particularly those involving motors and distribution blocks, understanding and adhering to the NEC is crucial. Let's delve deeper into the specifics of wire sizing and overcurrent protection. The primary concern is to ensure that the conductors used in an electrical circuit can safely carry the intended load without overheating. Overheating can damage the insulation of the wires, leading to short circuits, ground faults, and potentially fires. The NEC addresses this by providing tables, such as Table 310.16, which specify the allowable ampacity of conductors based on their size, insulation type, and insulation conditions. Ampacity refers to the maximum amount of continuous current in amps that a conductor can carry without exceeding its temperature rating. When sizing feeder conductors, it's essential to consider the load they will be serving. In the case of a motor starter, the load is the motor itself. Motors typically draw a significant amount of current, especially during startup. The NEC requires that the feeder conductor supplying a motor be sized no smaller than 125% of the motor's full load current rating. This accounts for the inrush current that occurs when the motor starts. Furthermore, the overcurrent protection device, such as a fuse or circuit breaker, must be selected to protect both the conductors and the motor. The NEC specifies the maximum allowable size of the overcurrent protection device based on the motor's full load current, starting current, and other factors. It's important to consult the appropriate NEC sections for specific requirements related to motor protection. Now, let's address the distribution block. A distribution block is a convenient way to split a larger conductor into multiple smaller conductors. However, it's crucial to ensure that the smaller conductors are properly protected. In the example provided, the 12 American wire gauge wire after the distribution block is undersized and unprotected. If a fault occurs in the circuit served by the 12 American wire gauge wire, the 125 amp incoming service would not provide adequate protection, potentially leading to overheating and fire. To correct this, a fuse or a circuit breaker must be installed before the distribution block to protect the 12 American wire gauge wire. The size of the overcurrent protection device should be based on the ampacity of the 12 American wire gauge wire, as specified in NEC Table 310.16. For example, if the 12 American wire gauge wire is type THHN copper wire installed in a dry location, its ampacity is typically 20 amps. Therefore, a 20 amp fuse or circuit breaker would be appropriate. In summary, the correct installation procedure involves firstly determining the full load current of the motor starter. Secondly, sizing the feeder conductors to at least 125% of the motor's full load current, consulting NEC Table 310.16 to ensure the conductors have sufficient ampacity. Thirdly, selecting a fuse or circuit breaker to protect the feeder conductors and the motor, following the NEC guidelines for motor overcurrent protection. Fourthly, installing a fuse or circuit breaker before the distribution block to protect the smaller conductors, sizing the overcurrent protection device based on the ampacity of the smaller conductors. It's crucial to remember that the NEC is a comprehensive document, and it's essential to consult the specific sections that apply to your particular installation. Additionally, it's always recommended to consult with a qualified electrician or electrical engineer to ensure that your installation meets all applicable codes and standards. Ignoring these guidelines can lead to serious consequences, including electrical fires, equipment damage, and personal injury. Therefore, prioritizing safety and compliance with the NEC is paramount when working with electrical systems. Furthermore, consider the practical implications of using undersized conductors. Not only does it create a safety hazard, but it can also lead to performance issues. Undersized conductors have a higher resistance, which can cause voltage drop. Voltage drop can reduce the performance of electrical equipment, such as motors, causing them to run hotter and less efficiently. In severe cases, voltage drop can even cause equipment to fail prematurely. By using properly sized conductors, you can minimize voltage drop and ensure that your electrical equipment operates efficiently and reliably. In addition to wire sizing and overcurrent protection, other factors should be considered when designing and installing electrical systems. These include grounding, bonding, and surge protection. Grounding provides a low impedance path for fault current to return to the source, helping to prevent electrical shock hazards. Bonding ensures that all metal parts of the electrical system are electrically connected, reducing the risk of voltage differences that could cause shocks. Surge protection protects sensitive electronic equipment from voltage spikes caused by lightning or other electrical disturbances. The NEC provides detailed requirements for grounding, bonding, and surge protection. It's important to follow these requirements to ensure the safety and reliability of your electrical system. Furthermore, consider the importance of proper documentation. Maintaining accurate records of your electrical system, including wire sizes, overcurrent protection device ratings, and grounding and bonding connections, can be invaluable for troubleshooting and maintenance purposes. These records can also be helpful when making modifications or additions to the electrical system in the future. In conclusion, ensuring the proper wire sizing before fuses is a critical aspect of electrical safety and compliance with the National Electrical Code. By following the NEC guidelines and consulting with qualified professionals, you can minimize the risk of electrical hazards and ensure the reliable operation of your electrical equipment. Remember, safety should always be the top priority when working with electrical systems. To further illustrate the importance of these concepts, let's consider a few additional scenarios. Suppose you have a motor starter that is rated for 50 amps. According to the NEC, the feeder conductors supplying this motor starter must be sized no smaller than 125% of the motor's full load current, which in this case would be 62.5 amps. Consulting NEC Table 310.16, you would need to select conductors with an ampacity of at least 62.5 amps. For example, you might use number 6 American wire gauge copper conductors with type THHN insulation, which have an ampacity of 65 amps. The overcurrent protection device for these conductors should be sized according to the NEC guidelines for motor protection, which may allow for a higher amp rating to accommodate the motor's starting current. Now, suppose you want to run these conductors to a distribution block and then split them into multiple smaller conductors to supply different loads. Before the distribution block, you would have the 6 American wire gauge conductors protected by the appropriate overcurrent protection device for the motor starter. After the distribution block, each of the smaller conductors would need to be protected by its own overcurrent protection device, sized according to its ampacity. For example, if you were using number 12 American wire gauge conductors with an ampacity of 20 amps, Each of those conductors would need to be protected by a 20-amp fuse or circuit breaker. Another important consideration is the ambient temperature in which the conductors are installed. The ampacity of conductors decreases as the ambient temperature increases. Therefore, if the conductors are installed in a hot environment, you may need to direct their ampacity accordingly. The NEC provides dirting factors for different temperature conditions. It is also crucial to consider the type of load being served. Different types of loads have different characteristics that can affect the required wire size and overcurrent protection. For example, inductive loads such as motors can cause voltage transients that can damage equipment. Therefore, it is important to use surge protection devices to protect against these transients. In addition to the technical aspects, it is also important to consider the legal and regulatory requirements. Electrical installations are typically subject to inspection by local authorities to ensure compliance with the NEC and other applicable codes and standards. Failure to comply with these requirements can result in fines, penalties, and even the shutdown of your electrical system. Therefore, it is essential to obtain the necessary permits and inspections before starting any electrical work. Furthermore, it is important to maintain a safe working environment when performing electrical work. Always energize the circuit before working on it, and use appropriate personal protective equipment such as gloves and eye protection. Never work on live electrical equipment unless you are specifically trained and authorized to do so. Electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself and others. To summarize, the key takeaways regarding wire sizing before fuses are: firstly, always consult the National Electrical Code and other applicable codes and standards. Secondly, determine the full load current of the equipment being served. Thirdly, size the feeder conductors to at least 125% of the equipment's full load current. Fourthly, select an overcurrent protection device to protect both the conductors and the equipment. Fifthly, install overcurrent protection devices before any distribution blocks to protect smaller conductors. Sixthly, consider the ambient temperature and direct the ampacity of conductors as necessary. Seventhly, use appropriate surge protection devices to protect against voltage transients. Eighthly, obtain the necessary permits and inspections before starting any electrical work. Ninthly, maintain a safe working environment and use appropriate personal protective equipment. Tenthly, consult with a qualified electrician or electrical engineer if you have any questions or concerns. By following these guidelines, you can ensure the safety and reliability of your electrical system.